This conference will now be recorded.
Mainly, Docker is a tool using which we perform container orchestration. Now, without wasting any time, let me directly go into what are containers and all that stuff. Look at my screen. If you actually go probably a decade back, some maybe 12 years back or something like that, when the virtualization market, the virtualization technology came into the market, you see that it was a very big boom because that was the fundamental concept based on which your entire clouds are running. Whether it's Amazon cloud or Google cloud or Microsoft Azure, you will see that all of them are running on the virtualization platform. The Docker, what we are learning over here, implements containerization, which is much more advanced than virtualization. It is one step ahead of your virtualization. What happens in virtualization, we'll try to first understand the basic architecture, and then we'll move into containerization, where we will see how Docker is a better replacement for virtualization in a lot of scenarios. Okay, so please look at my screen. Currently, I am talking about virtualization, which most of you are aware of. I'm sure that you have the habit of installing VMware, and on top of VMware installing your guest operating systems, and on the guest operating system you install whichever application we want, right? Now please watch. Generally, the architecture of your virtual machine starts with your brand new server, which we call as a bare metal. On this bare metal hardware, we install some operating system, which is our original, the main operating system, which in my case is Windows. Probably you also might be using Windows or Mac. So that's the host operating system. And on top of the host operating system, we install a virtualization software, which is called as a hypervisor. Examples of hypervisors are your VMware, your Microsoft Hyper-V, Citrix Zen. All these are different types of hypervisors which are available in the market. Your Oracle VirtualBox. Okay, and on top of the hypervisor, we install the the guest operating systems. Imagine that this is my guest OS 1. Imagine that this is my guest OS 2. You can say that maybe this is Red Hat Enterprise Linux, and maybe this is Windows 2016 Server Edition. So you see, though my original operating system is a regular Windows 10 OS, doesn't matter. On top of that, once the hypervisor is installed, hypervisor in the sense nothing but your VMware or Oracle VirtualBox, the hypervisor is enabling me to run different operating systems at the level of application layer, and on top of this I can install whichever applications I want. Imagine on the Red Hat Linux operating system I am installing Oracle database, whereas on the Windows 2016 I'm installing Microsoft SQL Server database. Okay, so see, please understand, basically we have two types of softwares. One is called as a system software and other one is called as an application software. What is the difference? System software is something that can always interact with the hardware. That is called as a system software. Whereas application softwares are those softwares which always require the help of a system software to interact with the hardware. For example, if I bring a brand new server or a laptop on which currently operating system is not at all installed, nothing is there, it's just a brand new server. On that server, can I directly install MS Office? Can we directly install Skype? That's not possible. You have to have an operating system. Only after installing an operating system, on top of that, you install the application, whether it's MS Office or Skype or whatever. So what happens when the Skype is running? It consumes some amount of hardware resources, memory, CPU, whatever. So the inability is Skype cannot directly interact with the hardware. Skype only interacts with the operating system. It's the operating system's responsibility to interact with the hardware and provide whatever hardware resources are necessary for Skype. So application layers, application softwares always take the help of system software. System softwares generally are operating systems. Though we say OS, system software is any software which can directly interact with the hardware. Okay, so application softwares are always installed on top of the system software. Now the problem comes over here. The problem is there are applications which are designed to work on specific operating systems. You can't say that every application will run on every operating system. I'll give you a very simple example which we are all familiar with. Imagine I want to download and install Skype. So what will I do? I go to the Microsoft site, I see Skype over there, I download it. Once I download it into my machine, into my Windows machine, I'll get a setup file. I just double click on it, next, and in just a matter of 1 or 2 minutes, Skype will be installed. Now the Skype file which I have downloaded, the exe file or the setup file that I have downloaded, can I give it to my friend who is using a Linux machine or a Mac machine and ask him to install on it? I hope you are understanding what I'm saying. The Skype setup file or exe file which I have downloaded, which has been designed to work on Windows, can I give it to some of my friends and tell them that you install it on a Linux machine or a Mac machine? No, that's not practically possible, right? It doesn't work in that way. It does not mean that Skype will not work on Linux or Mac. If you go to the Skype site, okay, the download site, there you will find that they'll show you Skype for Windows, Skype for Mac, Skype for Linux. So you have to download the corresponding version for that operating system and then it will work, which means every application that we are using has some dependency on the operating system. Applications are designed for specific operating systems. You can't take a common application and you can say that this will work on every kind of operating system. That doesn't happen. Applications are designed to work on specific operating systems, and that application will work only as long as you have that operating system. Now here comes the challenge. The challenge is in a real-time scenario where you are trying to create an architecture of multiple containers. Through Docker we will be implementing heavily what is called as microservices. So please try to understand what I'm saying. So in a real-time scenario where you will be actually trying to work on different types of applications based on the client's requirement, and unfortunately imagine that these applications are designed in such a way that some applications are running on a Windows operating system, some applications are running on a Red Hat Linux. It depends on different operating systems these applications are running. Still the client is saying that I want all these applications, which means we have to maintain those servers. I have to maintain separately Windows servers, I have to maintain Red Hat Linux servers, etc., etc. So this is the problem. Earlier, when this concept of hypervisor was not there, when I was actually a student when I started learning Unix in my college days, at that time what we used to do is we used to create what are called as dual boot machines, which means when you're starting your laptop itself, it'll ask you whether you want to go into Windows or Linux. I can choose whichever operating system I want and it will load only that operating system. But currently what we people are able to do, either we are using cloud or on our machine itself using VMware or Oracle VirtualBox, we are able to manage multiple operating systems as simply as you maintain your regular softwares, MS Office or Skype or anything, how you run them as applications. Similarly, the operating system itself, you are able to run as an application. That is done only because of this technology called as hypervisor. Okay, but I'll tell you why we actually require multiple types of operating systems. Imagine that in your organization currently the database is running on SQL Server. SQL Server, as all of you know, is compatible with Windows operating system because it's a Microsoft product. SQL Server is a database which is running on a Windows operating system. Now your organization feels that they want to migrate this into a Oracle database which runs on a Linux operating system, which means I have to maintain a Linux operating system, I have to maintain a Windows operating system, on top of which I can have these two different databases, and maybe the database admins will take care of the migration, how to move the data and all that. But the challenge that is happening over here is these applications have to pass through so many layers in order to access the hardware resources, because when this Oracle database is running, obviously this Oracle database also wants to consume some amount of hardware resources. So what the Oracle database will do, it will interact with the guest operating system, which is Red Hat Linux. Red Hat Linux will talk to the hypervisor. Hypervisor will communicate with the host OS, and finally host OS will decide, it will talk with the hardware, the bare metal. So the applications which are running on these VMs have to pass through so many layers in order to access the hardware resources. That is one of the reasons why you will see that when you are using VMware and if you try to install multiple virtual machines, if you start all these virtual machines, you will see that the performance will drastically go down. It goes down very much. You just create 4 or 5 VMs, you will see that your laptop becomes extremely slow. Okay, the same thing happens on your servers also, but probably they have much more bigger capacities, nothing more than that. Okay, so this is the main process of how a virtualization actually works. Now containerization comes, what Docker is doing, how Docker is actually solving this problem. We'll try to understand. Please see. I told you just now that every application has some dependency on the operating system, right? Every application that we are using has some dependency on the underlying operating system. What Docker achieves is called as process isolation. Process is nothing but your application, okay? Process isolation simply means the dependency the dependency that this application is having on the operating system, it is removing that dependency. Try to understand what I'm saying. Every application is having a dependency on the underlying operating system. In my case, SQL Server, maybe it's working only on Windows. I am trying to use a particular flavor of Oracle which works only on Red Hat Linux. Now, what it does is it will remove this dependency, which means now Docker enables you to run these applications directly on the Docker engine without worrying about what operating system is actually required. Let me first show you how the architecture of simple Docker actually works like. Please see. Imagine that this is my hardware as always. You can also call it as bare metal. And on top of the hardware, I have my host operating system, which is my Windows. In my case, it's Windows. You might be using something else. And here on top of this, we install a software which is called as the Docker engine. And on top of the Docker engine, you can directly start installing whatever applications we want. For example, I want Oracle database. Similarly, I want Microsoft SQL Server database. So earlier, what was happening? These applications had some innate dependency on an operating system. SQL Server was saying that I will run only if I have Windows Server. Oracle database was saying that, okay, you provide Red Hat Linux for me. Now you are removing that, which means the dependency that an application has on an operating system is eliminated, and these applications are created in such a way that they can directly work on Docker engine. Directly they can work on Docker engine. Now you can clearly see in this diagram that these applications have to pass through less number of layers in order to access the hardware resources. Okay, that's one advantage. So due to that reason, you see that it's much more faster compared to your regular virtual machines and all that. Now, let me tell you something interesting. The laptop that I am currently using, on which I'm taking your classes, you know, it has 8 GB of RAM and it has 1 TB of hard disk. Okay, this is my hard disk configuration. This is my 8 GB of RAM and it's running on some i5 processor, something like that. Okay, this is my configuration. Now you tell me, with this kind of configurations, if I try to create virtual machines on VMware or Oracle VirtualBox, if I'm trying to create virtual machines, how many VMs can I create and run them parallelly effectively? Maximum 5 or 6, not more than that, because the host machine, the main operating system, will require minimum 2 GB of RAM. The Windows that I am using as my host operating system, that will require nothing less than 2 GB of RAM. On top of that, I create some VMs. Probably each VM would, for decent performance, will require at least 1 GB of RAM or so. So maximum 5 to 6 VMs we can create, and that too, those 5-6 VMs if I create, and if I start all those 5-6 VMs parallelly, you will see that the performance will drastically go down. The performance of my machine will drastically go down. But on the same machine with the same kind of architecture, with the help of Docker, maybe I can create 500 or 600 Docker containers. Again, I'm repeating that 500 or 600 is just a tentative figure that I have taken. There is no limit. Of course, it does depend on the hardware resources, but Docker actually uses the hardware resources much more effectively than what a virtual machine can generally do. compared to what a virtual machine can perform. You will see that Docker can do that in a much more effective way. Okay, Sunny, just a second. What is your question? Docker will itself depend on operating system. So if more apps are installed on Docker engine, it will consume more resources, isn't it? Yes, Docker depends on operating system, Sunny. Okay, but you know the main thing is that Docker can be installed on any operating system. Okay, any operating system in the sense you have Docker for Windows, you have Docker for Linux, Docker for different operating systems. Once Docker is installed on that operating system, I'll tell you one advantage. Of course, hardware resources, that problem is always there. You need to have sufficient amount of hardware resources, but compared to virtual machines, Docker consumes less amount of resources. But let me tell you, imagine that this is my operating system, which is Windows, and on top of the Windows I have installed Docker, and on top of the Docker I am running Oracle database. Now I want to migrate this Oracle database into your machine, and your machine is not running on Windows, it is running on Linux. And of course, on this Linux also, you have installed Docker. Now, I can migrate this Oracle directly from my machine into your machine, and you will see that the Oracle comes into running condition. Though I was running Oracle on Windows and you are attempting to run the same Oracle on a Linux machine, it does not distinguish, because according to Docker, these things are not running on the operating system. They are running directly on the Docker engine. They are directly running on the Docker engine. So that is the main advantage. Process isolation, that's the word that we are coining. Process isolation simply means that the dependency, every application that you are using is having some kind of dependency on the operating system. Docker is removing that dependency. Docker is saying that you can run this application, and you can run it in such a way that further it will not have any dependency on the operating system. So everything will be running directly on the Docker engine, which means once these things are running on the Docker engine, I can just migrate these applications from different machines, from one operating system to another operating system. So it literally becomes platform independent. Irrespective of which operating system you are using, still the same application I will be able to use. See, the end user is not mainly interested in system softwares. End user or client is always interested in application softwares. You and I are interested in using MS Office or Skype or something like that. We are not interested in operating systems, but we have to learn operating systems and we have to know how to use it, because applications are depending on the operating system. Until that operating system is present, that particular application is not working. So for the sake of the application, why do we load the Windows operating system? Not because of the features which are present in Windows. We are primarily interested on the applications that we install on top of the Windows, right? That is our main interest. But in order to use those applications, it has become mandatory that I have to have the operating system. Now, Docker is removing that dependency. So what is happening? A person is running a particular Docker container on a Linux machine. The same Docker container I can migrate into some other person who is using a Windows machine. That is the main advantage. It's almost achieving platform independence, because it's actually removing the dependency that application has on the operating system. It is creating these applications in such a way that they will work directly on the Docker engine, without any dependency on the operating system. Once they start running on the Docker engine, I will be able to migrate it into any machine where Docker is present. Okay, that's one thing. We'll try to explore much more interesting factors, I mean, as we go. Now listen carefully. This is one concept that we need to understand. The second thing is, I told you that if I want to create on this laptop which I'm using with 8 GB of RAM and all that configurations, maybe I can create 5-6 VMs. And you tell me, based on your experience, how much time does it generally take for installing an operating system? Let us say I bring a ISO image, okay, a brand new ISO image of Windows or Red Hat Linux or whatever, and via that ISO image, I want to do an installation. I want to do an installation of my operating system, maybe on your VMware or directly on your physical machine. Irrespective of that, if I want to do an installation, you tell me generally how much time do you think it will take? Nothing less than 40-45 minutes, at least half an hour. Yeah, Rahul, 60 minutes, I accept that. It's very much possible that when you are trying to do a fresh installation, it might take 45 minutes or 60 minutes or something like that. So That is the time that we have to spend on installing a fresh operating system. Now Docker comes into picture. You know what? With Docker, we'll see that practically starting from tomorrow itself. With Docker, I can do that fresh installation of Windows OS or Linux or whatever you want in less than 2 seconds, not minutes. 2 seconds. We'll practically see that. I want a Ubuntu operating system. Docker will create that in just a matter of seconds. Before you can just close and open your eyes, before you realize what is happening, you will have a fresh installation of Ubuntu coming into running condition. It's not just about operating systems, it is about applications also. You tell me, you just name the application that you want, and Docker 90% those applications will be available in the format of images, and Docker will create that application in just a matter of seconds. I want to install Oracle database. Now you ask a database admin how much time they'll take for installing this Oracle database. They'll say that it takes half an hour, 45 minutes or something like that. Docker will do that in seconds. So any kind of development environment, testing environment, I mean, as we go with the sessions, these are the different types of architectures that we will see. We will create a development environment where a WordPress container will be linked with a MySQL container. Similarly, we'll see another development environment where you will see that LAMP architecture will be created. You know what is LAMP? Linux is the underlying operating system. PHP is the software used by developers for coding. MySQL is a database that is used for database technology. And Tomcat, Apache Tomcat is the application server. All this running on Linux, LAMP. This complete architecture, which is an open source architecture used in a lot of companies where Linux is open source, PHP is open source, Tomcat and MySQL, everything is free, but still you are able to maintain your complete development environment. We will try to see how to create all these kind of environments rather than going with the traditional process of doing the installations. Docker will simplify that process and you will be able to create that in just a matter of few seconds. The complete environment can be spinned up. Okay, how it happens, we will try to understand. LAMP, L stands for Linux, A stands for Apache Tomcat, M stands for MySQL, P stands for PHP Prasanna. So this is just an environment where developer can create his necessary environment, whatever you want, where coding happens via PHP, application server is Tomcat, and backend database is MySQL, everything running on Linux. Okay. Similarly, there are organizations where they use LNMP. LNMP stands for Linux, N stands for Nginx. In the place of Apache Tomcat, they use Nginx. Of course, M for MySQL, P for PHP. So any of these things, we can. Once I show you this architecture, you will be able to create any other type of architecture. Okay, that's not a big issue. But let's try to understand some more interesting concepts related to Docker. See, if I say, I mean, some of the other advantages. If I say, let's say this is my Windows machine, and if I want to take a backup of this machine, if I want to take a backup, generally what do? We bring an external hard drive, and whatever important files are there, whatever important data is there, all that data we will just copy into the external hard drive, and then later maybe I'll format this laptop. So whenever you just talk about taking a backup, generally backup happens only at the level of the data. My photos, my videos, my files, documents, PDF files, Excel files, all those things only I can take a backup. We can't take a backup of the applications which are installed. Imagine that Oracle is already installed over here. Imagine Skype is already installed. MS Office is already installed. You don't take a backup of those applications. We take a backup of the data present in the application. That's it. If I format this machine, again on the new laptop, I have to install Oracle. I have to install Skype. I have to install MS Office. Then I can start using those files. All of you are aware of this, right? Generally, when we take a backup, it's only of the data that is present. But now Docker says that not just the data, you can take a backup of the entire environment. For example, when I say entire environment, it includes the operating system along with the applications which are installed, along with the data which is present. You can just take a backup of everything as simply as you copy a regular file. For example, the file which is present on my desktop, if I want to take a backup, it's just 1 minute activity. I'll insert a pen drive and copy and paste that file. How simply you can take a backup of your regular files which are present on your machine. like that only we can take a backup of the entire environment. Environment in the sense it represents the underlying operating system, the applications which are installed on it, and the data which is present. And once you take a backup, and if I take this backup container and if I put it into some other machine, in that some other machine, again that complete environment will spin up. I hope you are understanding. This is the potential of Docker. So you are able to take a backup of everything. You can just copy that Docker container from one environment to another environment as simply as you copy a regular file. Okay, I'll show you something else.
I'm sorry, I'm disturbing you. You mean to say you're cloning a machine, or you're just giving a replica of that?
We don't use the word clone over here, and replica is used in different context in container orchestration. So I don't want to use that word. I just want to use the regular word, like how do you take a copy of a file which is present on your machine, on your Windows machine. I want to take a copy of a PDF file. I'll just copy it into my pen drive, right? How simply you are doing that. In the same way we can copy. So let's just use the word copy itself. It's not cloning, it's not replicas. Regular copying, but copying of the entire environment can be done. Similar thing is happening in cloning when you use VMware and all that stuff. But here we call it as copy. But there are limitations in VMware. When you do the cloning and all that, that cloning happens generally on the same virtualized environment. Whereas in Docker, I can create that copy and I can move it from one machine to another machine. You know, the example that earlier Sunny was asking, imagine that I am having something like this. This is my original server where I am running things on Windows. On Windows, I have installed a Docker engine, and on top of the Docker engine, I have created a Ubuntu container. Now this Ubuntu container, I want to move it into my friend's machine, which is running on Red Hat Linux. There also Docker is installed, but the same Ubuntu image I want to copy. So copying from one environment to another environment can be done as simply as you copy files. When I say copying this Ubuntu operating system, what it means is not only the OS, along with the OS, whatever applications are installed, whatever data is installed, everything will get copied into the new environment. That can be done. Okay. And the Docker documentation says that Docker can be used at all the stages of build, ship, and run. Today's session is more or less more theoretical because we just need to understand what is containerization. The actual part of installation and all that we will see, but once everyone is clear with the basic part, things will become much more easy for me. Build, ship, and run. Docker says that you can use it at all these three stages. Now what does that mean? I'll give you an example. I'm sure most of you have already experienced what I am talking about now. Listen carefully. We call this as the blame game. Generally what happens in organizations is, imagine there's a team of developers who are creating some application. Obviously there's another team of testers who will test that application. Developers and testers, they check that up, they create it, they test it, it goes through multiple iterations. Finally they come to a conclusion that it's a proper working version of the software, and then it is released, which means it goes live, it's deployed into the production environment. Once it goes live, once it is deployed into the production environment, just imagine that it's not working properly. It's creating some issues. Some kind of problems are coming, and the client is not, he's complaining that this is not working, that is not working. Now, the development team and the testing team says that it was working fine in our environment. We have created it properly, and testing was also done. Maybe there is some issue in the production environment. So first of all, fix the production environment. The servers itself, there is some problem. The people who are managing that infrastructure on the production environment, they say that on these servers, other applications are working properly. There is issue only with this application. So there is some problem with the development of the code itself. So you call it as a blame game. People are just putting the blame on someone else. How will your management try to understand where the problem is actually coming from? Is it really issue with the production environment, or is it really a problem with the creation of the application? Very simple. Docker can solve that. Docker says that you can use it at all these three stages, wherein the same environment where the application is built, you can ship that environment and you can run it in the production environment. Which means Now there is no scope of someone saying that in my environment it was working and in their environment maybe it's not working, because it's just the same environment. That was what I was saying a few minutes back. You can copy the entire environment as simply as you copy files. How you copy a regular file, in the same way it is possible to copy the entire environment. Something like cloning, you can clone that entire environment and you can move it into different hardwares and different operating systems. And because it is the same environment, there is less scope of people saying that earlier it was working on my machine, on my environment, maybe there is some problem in the other production environment. The same thing can be copied. So we say that Docker can be used for building, shipping and running, and we'll practically see that. I mean, we will understand how we can create our own customized Docker images, how you can bundle them, how it is implemented in production using Kubernetes. All those aspects in detail we'll try to see as we go with the sessions. Okay. So one advantage, as I told you about Docker, is you are able to spin these Docker containers. Okay, we don't call them as VMs. They are not virtual machines. We call them as containers. Containerization and virtualization both are different. I gave that definition, right? Both are different. Containerization is much more advanced. In containerization, what we are doing is we are trying to segregate the process isolation. We are removing the dependency that an application has on the underlying operating system. We are just spinning that process. We are able to create that process in just a matter of seconds. And when I use the word process, the process can include an operating system also. Okay, Ubuntu as an operating system can also be created as a container over here. Red Hat Linux can be created as a container. A database can be created as a container. Jenkins can be created as a container. Tomcat, anything can be created as a container. And this container creation takes just a few seconds, 1 second or 2 seconds, not more than that. Okay, so creation of the necessary environment, spinning of that environment can be done very effectively and very easily. That's one thing. Huge amount of the hardware resources are used very effectively when you use Docker. Okay, how it happens, I'll show you with another diagram. Just watch. Imagine this is my Prasanna, what kind of maintenance you're talking about? I did not understand. Imagine this is my host operating system, and on the host operating system we have our Docker engine, and on top of the Docker engine, imagine I'm running two Docker containers. One is a Jenkins container and other one is a Tomcat container. Okay, now in Docker, directly when these containers are created, we don't do any fixed hardware allocation. For example, if you people have installed any VMs on VMware, at the time of creating that VM itself, it will ask you that, I mean, how much amount of RAM you want to give, how much CPU you want to give, how much hard disk you want to give. You give the specifications, and based on that, the VM is getting created, right? Whereas in the case of Docker engine, you don't need to do that. You just simply start these containers, and when these containers are running, depending on the amount of process which is running, the Docker engine will dynamically allocate more amount or less amount of hardware resources. So fixed amount of hardware allocation is not happening. If Jenkins container is running a lot of processes and Docker engine sees that it requires more amount of RAM, more amount of CPU, Docker will automatically on runtime, without that Jenkins container going down, we call it as hot swap. On runtime, more amount of hardware resources will be allocated. Similarly, Tomcat container is not doing much activity, so less amount of hardware allocated. Yeah.
Can you let me know how does it happen in the live environment? How it assigns it the new RAM or the new space?
See, internally, Ramakrishna, what is the protocol using which it assigns? I can't show you. What I can actually show you is I can start those containers, and you will see that when I'm running multiple processes on it, the amount of RAM that it is consuming is fluctuating. It can increase or it can decrease. Internally, how Docker engine is managing that, what is the technology? I don't know. I mean, we can't explain that. We can simply say that it is giving, it's not using fixed amount of hardware allocations. And live example I can show you. When you run these containers, I can clearly show you that none of them are running on any fixed hardware allocation. But how that hot swap is happening, how more amount of RAM is getting allocated, no one can tell. Why talk about more amount of RAM? No one can answer, even if you ask how fixed amount of hardware resources are allocated.
No, you're misquoting my question. It was not my question. Was not that. My question was that suppose if I'm giving my container, suppose 8 GB of RAM, and tomorrow I need around 12 GB of RAM for that. How does it take it?
No, Ramakrishna, I did not say that, Ramakrishna. we are not even, we never said that we are giving 10 GB of RAM for the hard disk, and we are never saying that it will be enhanced to 12 GB. What I am saying is, when the Docker container is starting, you are not even saying that this should run on 10 GB or 12 GB. You are not even talking about any hardware resources. When the Docker container is running, automatically Docker will do the hardware allocation. It can be 10 GB or 12 GB or more, it doesn't matter. We are not specifying any fixed amount of hardware allocation. When the containers are running, depending on the process that is running, Docker is deciding that. But there is a small catch over here. If I want, I can put an upper limit in the sense, because as I told you, Docker engine is dynamically allocating the hardware resources. Now, let's say I'm using a Oracle database, and I feel that this Oracle database keeps on expanding, and if it consumes more and more amount of hardware resources, I don't want to cross beyond a particular limit. Then I can put an upper limit saying that this Oracle database should not go beyond 10 GB. So it will ensure that it won't go beyond 10 GB. But if you don't specify anything, if I simply start a container using the regular Docker run command, none of these containers would be given any fixed amount of hardware allocation, except for loading that basic OS or basic application, whatever minimum level of RAM or CPU is necessary, only that much will be consumed. When the container starts running, and when you do a lot of process in it, depending on the amount of processes which are running, your Docker engine is either giving more amount of hardware resources or less amount of hardware resources. So when you're starting, you're not even talking about how to give or how much to give.
So you mean to say that the hardware part, suppose if I have around a server, keep it as a Dell server, it has around 60 GB of memory, okay, and I put a Docker engine on that, so the complete 60 GB will be dedicated to my containers.
No, I did not say that. When these containers are running, let's say that you have started an Oracle container. That Oracle container, imagine that it's taking only 1 GB of activity. The kind of work that is happening is consuming only 1 GB. So it will take only that 1 GB. Why will it take about all the 60 GB? But if you don't put an upper limit, and if this Oracle database is constantly doing a lot of processes, yes, it can expand to that extent where, leaving that host operating system, whatever available memory is there, all that memory it can consume if you don't put an upper limit.
Okay. No, I'm new to this. Sorry, but I'm getting it a bit late.
Fine. I mean, Ramakrishna, we will be actually seeing all these things practically. Once we start Docker containers, you will see how that hardware allocation and all those things are done. So that should not be a problem. That's one thing. And the second thing is, we were actually talking about, one of the questions you asked, the question was, you put in a different way. You said that imagine you're starting a container with 10 GB and now you want to upgrade it to 12 GB on runtime. How does it do that? No, we don't do that. But that is also possible. That happens in container orchestration. In container orchestration, you can actually create containers in such a way that I will put a fixed amount, upper limit 10 GB, and I will see that after a point of time, I see that though initially I have given 10 GB as the upper limit, I'm not satisfied with that. Maybe if I have a little more, it would be better. So I will give 15 GB as the upper limit. Without experiencing any downtime, you can add those resources. That is done in container orchestration. Kubernetes and Docker Swarm will do that. Even that is also possible. So you put an upper limit, you're not satisfied with that upper limit, you can increase it or you can decrease it.
Got it.
I think I have some questions. Just a second. What I understand so far is we are just installing the software and application in Docker. So my question is, Docker will maintain all this with automatic without any human interaction. Human interaction is mandatory. Creation of that environment is done in a very simple way. That's it. That's the only thing that we are promising here. Okay, so Sahu, depending on which kind of application you are using, for example, if I want to start a MySQL container, Docker is just promising that I can create that container very effectively, very simply I can create. Once it is created, it's the responsibility of the database admin to go into the container and maybe necessary installation of the necessary databases and tables. Those things are mandatory. We are not talking about that. We are simply saying that the environment creation can be greatly simplified. That's it. Okay. And Sunny says, what will happen if all the memory will be consumed by any app if upper limit is not set? No, that will not happen. When you see, we'll constantly encountering this problem, because Sunny, I will be actually demonstrating this on the the AWS cloud, where the free instances that we use have only 1 GB of RAM, you will see that whenever we are out of memory, it clearly, when you try to start a container, it clearly shows a message saying that we are running out of space, you can't create these containers. So that's common sense. When the hardware resources are not available, Docker, no one can do anything, right? And that's it. I mean, I think I answered all the online questions. So, fine. The hardware resources are also handled more effectively if you're using Docker. So this is just a brief introduction towards making you, I'm just trying to make you understand what is Docker, what is containerization. I just want you people to have this one word in your mind, process isolation. If this is there, as we go with the sessions, things will become more and more clear. Docker is just removing the dependency that each application has on an operating system. It's enabling all these to run directly on the Docker engine. The advantage is you are able to create applications. See, I'll give you another example of why it is necessary. For example, let's say this is my architecture. You have your hardware, and of course you have your host operating system, and on top of the host operating system, I'm talking about hypervisor. Okay, so I have hypervisor like VMware or something, and on this I am installing my Windows 2016 server, because my intention is used to Microsoft SQL Server. Okay, so Microsoft SQL Server requires Windows 2016 to be installed. Just imagine. Okay, which means I have to purchase license for Microsoft SQL Server. I have to purchase license for Windows 2016 Server. I am spending money on the operating system. I am spending money on the application. Now Docker says that no need to do that. No need to spend money on the operating system, because these applications can be directly run where you are able to run them on the Docker engine. MySQL, Microsoft SQL Server, you don't need to say that it should run only on Windows 2016. I will just buy the license of the SQL Server and make it run directly on the Docker engine. So, the licensing cost can go down. Unnecessary dependency that these applications are having on the OS, you're removing that dependency. So, that's a very big advantage. Red Hat Linux is not a free software. I have to purchase a license for that. So Red Hat Linux, instead of buying Red Hat Linux, I will directly take Oracle license, and this Oracle I will run on the Docker engine. This Docker engine will be running on my host OS, and everything is running on my hardware. Earlier, Oracle I had to take, along with Oracle, I had to take a Red Hat Enterprise Linux. That's not necessary. So applications are directly running on your Docker engine without depending on the OS. How do I define containerization? I think that was what I was actually trying to do from the beginning of the session. Okay, the definition that Docker gives is the same thing that I have told you. Okay, we call it as process isolation, which you are segregating the process and its dependency on the OS. Why they give the word container is, if you actually look at the Docker documentation, the symbol, the icon, or what they show is a whale carrying those containers. What is a container? Generally in the shipping yard, you find those big boxes, right? Which are called as containers, which come in cargo ships and all that. We call that as a container. And Docker is a tool which is maintaining those containers. A container is nothing but a closed environment which can contain everything that is necessary for one application. Okay, it's just a closed environment where everything is present. I want Jenkins, so for Jenkins, imagine that I require Java. I want Tomcat, for Tomcat maybe some other application. So whatever is necessary for that application, everything is present in that closed environment that we call as a container. And this container is created in such a way that it does not depend on the operating system. It can be executed anywhere. That's the basic definition of what is a container, okay, according to my understanding. If you read the Docker official documentation also, more or less they'll show the same thing. Now, when it comes to installation of Docker, Docker comes in two flavors. One is called as Docker Community Edition, and other one is called as Docker Enterprise Edition. Okay, Community Edition is the free version of Docker, which we will be using, and Enterprise Edition is the paid version of Docker. Both are same. The only difference is, in the case of Enterprise Edition, you get support. Somewhere you are stuck up, the Docker community would be willing to help you to fix the problem. Whereas Community Edition is a free version of Docker. Obviously, we have to take care of everything. Okay, but apart from that, everything is same. Now Docker, as I told you, can be installed on Windows, Mac, Linux, anywhere. We will be learning Docker on a Linux machine. Okay, though I can install Docker directly on a Windows machine, I will be showing you how to install Docker on a Linux machine. Of course, I'll show you how it can be done. Yeah, in AWS only. On AWS, we'll create a Linux machine, and on the Linux machine, we'll install it. Okay, Prasanna. So uh, let's. I mean, though we don't practice Docker on Windows in our sessions, let me just show you how it can be done. If you are interested in installing Docker on a Windows machine, all I have to do is simply type Docker download. Okay, this is the distribution site of Docker. You can come here, download from Docker Hub. You'll get a setup file. Next, you install it. You see, it's a community edition, so it's a free version. You install it. So it just takes 5 minutes or 10 minutes. I'm not showing the Windows part because we are mainly working on the Linux, but there's a downside to this. Once Docker is installed on Windows, if you want to execute Docker commands, you have to open something called as a PowerShell. In every Windows machine, you will have this command prompt, which is called as the PowerShell, not the regular CMD prompt. This is the PowerShell. And this is the PowerShell where you have to fire the Docker commands. Of course, in my case, Docker is not installed on Windows, so I will not be able to run the Docker commands here. But once you download that setup file which I have shown you, you will be able to run the Docker commands and you get the corresponding output. Whatever Docker commands we are going to learn from tomorrow, you will see that the same commands will work on both Windows and Linux machine. There is no difference. Only the installation process is different. Okay. Apart from that, everything else is same. But there is a small downside to this. If you install Docker on a Windows machine, it will activate an application called as Hyper-V. Okay, Hyper-V is present on your Windows laptop by default. That's the virtualization software of Microsoft. But this Hyper-V is in deactivated position in all of our laptops. Once this Hyper-V gets activated, I mean, if you install Docker on Windows, Hyper-V gets activated. And once Hyper-V is activated, it will not allow any other virtualization software to run on your machine. I hope you are understanding. Once Hyper-V is activated, it will not allow any other virtualization software to run on your machine. Okay, I'll give you a, let me show you. If I go to my control panel, and if I try to uninstall a program, turn Windows features on or off. These are the default Windows features which are loaded when you install your operating system. Do you see there is an option called as Hyper-V? Fortunately, it's in unchecked position. But once you install Docker, that becomes checked. And once this Hyper-V gets activated, you will not be able to run VMware, Oracle VirtualBox. It does not support any other virtualization technology. It will not allow some other technology to run on your machine. You want, you can try it. Okay, I am not showing that because, and again, it will take another half an hour. And anyhow, our intention is to practice Docker on a Linux machine. So let's not waste time on it. But if you want, you can just do that. You download that setup file. You will be able to run the Docker commands directly in this PowerShell, but other VMs will not work. How will they get activated? Very simple. You uninstall Docker and you open this thing, uncheck this Hyper-V and restart your machine. Again, this will take 20 minutes, half an hour. Lot of updates happen, and finally your regular VMs and whatever is present, they will come into running condition. But as long as that Hyper-V is activated, you will not be able to go further. Okay, this is about Docker on Windows, though we are not interested in Windows. We will be starting tomorrow by installing Docker Community Edition on a Linux machine. Of course, I'll create an AWS instance, and on the AWS instance, I'll create a Linux machine. It need not be an AWS instance. It can be a virtual machine that you have created on VMware. Any Linux box is okay. It can be Ubuntu or CentOS. Don't use Red Hat Linux. Except Red Hat Linux, you use any flavor of Linux. The reason I'm saying don't use Red Hat Linux is Red Hat Linux supports only the enterprise edition of Docker, which is the paid version of Docker. On Red Hat Linux, it's not possible to install the community edition of Docker. We are using the free version of Docker for learning and practicing. In your organization, they'll be using enterprise edition, but here we are using community edition, and community edition cannot be installed on Red Hat Linux. So You use Ubuntu or CentOS or any other flavor of Linux is okay. That's not a problem. Amazon Linux or Oracle Enterprise Linux, anything is okay. Okay. The commands of Docker are just the same. That's one thing. And I think I have just given a brief introduction to Docker. Fine. And if you are interested in installing Docker on a Windows machine, there's one more thing. Docker can be installed only on Windows 10 64-bit version, professional version. Windows 10 professional 64-bit version. If you are using Windows 10 home edition or standard edition or some other basic editions, Docker cannot be installed. If you're using Windows 7 or Windows 8, Docker cannot be installed. So keep that in mind. Or else you can use Windows 2016 server. Obviously, you and I don't use Windows Server editions, right? So that is totally ruled out. Windows desktop that you are using, if it is 10 professional 64-bit version, you can directly install Docker. If you are not using that, don't waste your time on all this, because anyhow, in our entire sessions, we will be concentrating with Docker on a Linux machine. On Linux, we'll install and we'll try to see all those activities. So that is of more importance for us. Okay. So this was just a basic demo session where I wanted to give a brief description of what is Docker. Whatever we have discussed, including the diagrams and all that stuff, what is virtualization, containerization, and all that, I'll send it to you in the form of notes. Please go through that notes. If possible, if you have time, go through this video recording one more time, so that the terminology sinks. Tomorrow we will see how to install Docker, and I will also give you the list of some of the frequently used commands, very frequently used commands, and based on those commands we'll see how the environment creation and all that can be done. Okay, so friends, thanks a lot. I'll stop the session. Tomorrow we'll continue with the remaining concepts. Sunny, the questions that you have asked in initial part of today's session, I'll answer them. Okay, we'll go into that session and we'll definitely address those things. So bye all of you.
Thank you.
Yeah, thanks.